we'll be discussing today iterative design and how we balance these processes and how we use our creativity in this iterative design. This is quite interesting concepts, and I'll first like to give you some brief about what is design and how we go to the iterative design and why iterative design is important and why creativity is important as far as iterative design is concerned. Now, once we discuss about all these basic things, then what we will do is I'll quickly take one simple problem and I will demonstrate how we can use the concept of iterative design and how we can use that. There will be some questions which will I will pose in between, but however, those questions will not give or find the answers today, but perhaps when we'll interact live during our session, I will like to interact and hear from you about your answers. And I will also show some of the iterative design solutions. Very simple problem which I have brought today, and I will like to see your solutions, your ideas to find out the solution of that problem. So let's start with iterative design and quickly go through the basic concepts, and then what we'll do is we'll solve one simple problem. So when we talk about iterative design and creativity, naturally, one very important thing can come in our mind, and we want definitions or concept what is meant by creativity and what is meant by design. Once we understand what is creativity and what is design, then definitely we can find out what is meant by iterative design. So creativity is something where our imagination is very important and some ideas which are coming as a thought process. Okay, and that is very important, especially when we go and find out certain solutions as far as engineering product development is concerned or analysis is concerned. This imagination is very important because many times we imagine in front of our eyes few things are there, and we'll try to modify those things, we'll try to apply forces, we'll try to apply certain conditions, and after that we just try to visualize in a virtual world in front of our eyes in our imagination how it may look or how that effect may happen on that particular object or on that particular situation and what can be the outcome of that. Now, talking about this, it is not only what we see in our engineering or our day, just for product development, that happens even in our day-to-day life also. So creativity is something which is we can connect it to the problem solving with imagination, and it is really a more relevant concept as far as innovation and novelty is concerned. However, there are certain myths about creative. People think that only few people are creative, like artists are creative, and few jobs are only creative, and there are many other jobs or some other people are not creative, which is a myth. In fact, everyone is creative. Creativity can happen at any time and at any place, and it can be a very small thing which is creative, or it can be very a big thing like a out of the box idea or concept, which we talk about creativity. So creativity is more like a problem solving technique, we can say, which I will talk in terms of engineering background today, and connecting different dots of solutions to find out a complete solution. And that is what I can see as creativity in problem solving. And creativity basically there in every jobs, every work, or everything what we do in our personal and professional life. So creativity is very important. Okay, so what is design? And when we talk about design, there are many designs which we can see in the world. And in fact, you can definitely try to find out the answer of this question: what is your favorite design in the world? And it can be a product, it can be a structure, it can be a process, and design you can see everywhere. Do you think, do you have any other answer for this? What I have mentioned, what is your favorite design? What answer come in your mind? I would like to hear from you when we'll meet. Now, when we talk about what is design, this is a very unique question. And when we talk about design, as you will have different answers which will come out of this particular question. But when we talk especially about design, design is basically a noun also, and it can be a verb also. Design, we can say, is a power of human being to conceive certain ideas, okay, so to conceive certain plans, to realize their imagination into reality. So to find, so the journey of imagination from virtual world to the reality, we can call it as a design. And design is very important concept. You can see its applications is arts, engineering, architecture, and so many other fields. And when we talk about a design, it can be noun in terms of I design a plan, I design a product, I design a process, I design an object, and so many other things in general. Or it can be a verb to design, like we can say that it is a verb to design, and it's a process of designing something. And it can be designing a component, system, structure, process, or whatever it is. So, very important concept design, lots of definitions. But when we talk specifically about design, it many times we try to connect design with creativity and innovation. Okay, in fact, design is everywhere around us, and everything which is man-made and surrounding by us is basically design, either cautiously or may not be, but it is design. But believe me, what are the things which are not man made but which are found in nature, that is natural things, that things we can also say that are designed by nature. Okay, and we can always see the interaction between natural designs and human being what they design, and there's always interaction between that. And we can say that human beings are mostly inspired, or human designs are influenced by nature designs, and that is called as a nature inspired designs. And you can see that biomimicry and so many other fields where human beings are designing by taking the inspiration from nature. There are many examples of that. And design can be user centered design or use centered design, and there are again different varieties in that. But today we will talk more about engineering design, because when we talk about design, it's a broad area and so many things cover in design. But I'll talk more about engineering design today. And when we talk about engineering design, it is more about problem solving processes, and it is more like a structured way of solving the problem, because we apply certain scientific principles, we apply certain theories, we use mathematics, and we use general concepts of optimization, and we also do lots of analysis, testing, and iterations to find our final design, which can be acceptable, which can work. Okay, and no design in engineering is considered as final. Design keeps on evolving, and it keeps on evolving because as our analysis power changes, as our manufacturing processes changes, as our material property changes, as new material found, as testing and evaluation facilities changes, we keep on evolving, we keep on refining, we keep on processing our designs again and again, and we try to become better and better. And that is how you can see, and there can be different examples. And the best example, you can see that different versions of the iPhone, from iPhone 1 to what iPhone 10 and iPhone 11, whatever is there in the market, you can see that every version of iPhone is changing. It's in design processes, applications, and there are so many different features added, and that keeps on happening in every version. So that is how it happens as far as engineering design is concerned. And when we say that engineering design is iterative, that means we keep on doing different iteration. That means we keep on refining our design. So we do the testing. If we find certain processes to be improved if we find a certain material uh, can be replaced by a better material, if we can see that there are some different good properties which we can use, and we keep on changing and we keep on doing better and better, and that is called as a iteration process. That is what I was telling, and that is the main topic of today, how we do these iterations and how we find different solutions as far as this iterative design is concerned. Just want to give one very good example here about what is design when we call, and especially when engineering design we call, as we have seen that engineers can definitely create the world which was even not in existence. That is what we have seen in different particular technological based innovations. Engineers have found and designed so many different applications, and these are just some examples of that. Before going in detail about iterative design, natural question can come in mind: why design? So there are so many applications of design and so many benefits of design, but the most benefit which I see in today's world is the world is changing, the problems are changing, the challenges are changing, requirements are changing, and in this rapidly changing world, we require better designs, efficient designs, optimum designs. We want to solve the problems, and a lot of information is changing, the information is dynamic, and in this way, you can see that the world is becoming more interdisciplinary and multidisciplinary in nature. And we want for these new problems, and of course, uh, to connect different problems to find better solutions, we require design, and design is the answer of many real-time problems. So that is how I see as a design, and that is how I see that design can be the answer of many future problems and current problems. Now there are various ways how we make our designs, and one way of doing that is the concept of design thinking. Now design thinking is a basically human centered approach where we keep our user at the center of our problem, and we try to find out the solution of the problem by using who is the user of that particular solution and what can be the effect of that solution on that user. That is our entire focus, and based on that we find out the solution of the problem, and that is what is that about design thinking. Design thinking concept we can apply to solve our problems in many ways, and in many fields. However, today's focus of this session is basically we will be solving the engineering problem by using design thinking approach. So in design thinking, what we try to do is we try to find out the solution of the problem which is basically economically viable, technologically feasible, and from human perspective which is desirable. Okay, so basically we try to hit the center of viability, feasibility, and desirability. That's why you can see that even the use is same, but there are different designs as far as bridges are concerned. And that is the one example which is there on your screen. And you can see that for the same use, different designs in the different parts of the world. And that is where design thinking play a very important role. So when we talk about the concept of design thinking, basically it is clearly can be divided the entire process into 5 steps, and that is what is called as the 5 steps of design thinking. And it starts from empathy, then definition of the problem, ideation, prototyping, and testing. So I'll just quickly take you through all these 5 steps, and then we'll basically focusing more on ideation and iteration and prototyping. Okay, so empathize or empathy is the first step of this problem solving process. And when we talk about empathy or empathize, it means that we try to understand our user in a better way. We try to deep dive about the requirements of the problem solving, and we keep our user at the center. Once we do that, in the next step of definition or define, we clearly understand the problem with all the conditions and how and why we want to solve that particular problem. After doing that, the next step is very important, which is called as ideation. And in this ideate step, we brainstorm variety of solutions which are possible for the as a solution for the given problem, and we develop different types of solution. After brainstorming on that, eventually we shortlist or we conclude on maybe one or two final solutions, and we try to go to the next step, that is means we try to build a prototype of that. Now this prototype can be the actual prototype of or the hardware of a solution, or it can be a process, it can be a software, or it can be just a virtual prototype, and we simulate that in some softwares or in virtual environment. So there are variety of ways how we can build the prototype, but there are variety of ways. I'll not go in more detail about that, but it is not necessary that you always directly build the final product. With the computing power revolution, it is very easy to make a prototype with less cost, not always necessary to build directly the final product. Once we design the prototype, just go for testing. After testing, we find the results of that particular product. If we are happy with that, we try to deploy that solution to the user and take the feedback of that. However, during the testing, if we see that there are certain results which can improve or there are some issues related to that, we go back to the ideation, again work on that particular ideas, and we try to overcome the issues which are highlighted during the testing, and we build the prototype again and we test this prototype again. That means we repeat the third step, fourth step, and fifth step again, and we do keep on doing this again and again. That is ideation, prototyping, testing, ideation, prototyping, testing, and this process is called as iteration. That means we repeat these processes and we iterate our solution, and we try to bring the better and better solution, and that is ideation, prototyping, and testing. Now, when we talk about ideation, we have talked about building a prototype and testing. So, luckily, there are many softwares which are available nowadays and which we can use for building these virtual prototypes and testing. So, I will be talking more about CAD, CAM, and CA softwares, and I'll be demonstrating one very simple software how we use that for solving one problem today. But with respect to that, have you heard of CAD, CAM, CAE? Do you know what is mean by CAD, CAM, and CAE? Do you know any software? Have you used any software for such type of analysis? I'd like to know more about that. Definitely, we'll try to discuss this when we meet next time. So when we talk about product design and engineering, just one example I have taken of automotive systems, and there are so many other industries as well. But when we talk about this product design and engineering, generally we talk about the concepts of CAD, CAE, and CAM. And when we talk about CAD, we basically try to design the concepts and we detail out the designs. And when we talk about CAE, we talk more about validation and analysis and simulation and optimization of our solutions. And this is more related to engineering design. And when we talk about CAM, we talk more about manufacturing, and it can be traditional manufacturing or it can be additive manufacturing. You must have heard of many concepts of additive manufacturing recently, including 3D printers, but that is what is CAM, and we can talk more about that during our interaction. And we may get such type of solutions where we may have different types of analysis, and we can build different types of prototypes. Like here you can see a prototype, and you can actually see here that we can either study the flow and the patterns, and we see whether we are getting the solutions correctly or not. So this can be one prototype, and we can actually study the detail of the flows. And if we don't want to build such type of prototype and hardware itself, what we can do is we can simulate the same thing in the software. And when we simulate the same thing, we can still study in the virtual world what is happening, and how the flow pattern is, what is the temperature distribution is, what is the velocity distribution is. And we can use software and we can find out whether the solution is having any problems or it is as per our expectations or not. And there are a variety of applications other than industrial and biomedical applications for all such solution development and the design solutions, but I'll not go in those details today. Okay. So let me talk about the simple activity which I will demonstrate now, and I will like you to come up with some solution of the problems and what made you to think that that can be the solution of that, and I will like to hear from you about those solutions. So what we are going to do is we are going to build a simple plate like this, which I have already built in particular software, and I'll soon show you that. So what we'll do is we'll apply different forces on this. Okay, so you can see that this is a square plate and we have three circular holes in this square plate. Okay, this plate is fixed on one side, so we can say that this can be a bracket. Okay, and we will apply certain loads. Okay, so whenever we apply any forces or any pressure, it creates stress. So I hope you know what is mean by stress, but stress is basically the ratio of force upon area. So when we apply any force, it acts on particular cross section area, and that causes the stress in that particular area or in that particular material. Now if that stress is more than the capacity of bearing the stress of that material, then that material will fail. It may break down, it may crack, it may just cut at that particular it may just broke. So basically what we are going to see that this stress should not be more than the capacity of the loading bearing capacity of that particular material, and that is what we try to do generally when we try to find out such solutions. Okay, now here in this particular problem, what we are trying to do is we can see that we have a square plate with three different circular holes, and we apply different types of loads. Now when we apply the load can be perpendicular to the plate in this direction, and that causes the normal stress. And when we apply the normal stress, you can see that you are just pulling it from one side, and you can see here it apply when you apply it is basically just try to stretch the material along the force, along the direction of the force where you are applying. And you can see that there are some purple color, you can see here stretches, and even the blue color stretches which are coming in this range. It's difficult to see the red patches here, even though they are not. So this is high stress and these are low stress, but we can see some stresses here, and this is the fixed constraint. That means we are fixing the plate on that side. So these are normal stresses. Do you know what are different types of stresses? There can be different types of stresses like bending stresses, normal stresses, tensile stresses, compressive stresses, shear stresses, torsional stresses. It all depends on how you apply the force and how that particular force affects the material. Okay, and accordingly the definition changes. So basically this is one type of force, and that is perpendicular to the surface, and that is a normal stress. Now this is one example of shear stress where here we are applying the force in other direction, like this direction along the surface of the plate. And what this force try to do is it try to pull this one layer of this material from the another layer, and that is why it causes shear. It basically causes one layer of the surface to slide on the another layer, and it just try to pull that. Okay, and if you see what is happening here, and you can see that the pattern is totally changed, and you can in fact compare these two patterns here. Okay, so you can see that as we apply the forces in different direction, the effect on the plate is different. Okay, now you can see that how the particular stress distribution is changing here. These are the colors of the stresses, and you can see that this is more stressful here because the colors are mostly green and yellow in these regions, and you can see that a lot of stress is basically created because of this type of loading condition, and we call it as a shear stress. There can be a third type of category which I would like to show you, and that is von Mises stresses. Now, what is von Mises stresses is basically a concept which is used in solid mechanics and quite popular concepts. I'll not go in more detail about that, but basically von Mises stress is a resultant stress. Okay, and what we try to do here is that now we are just trying to change the loading condition, and instead of applying it on the surface, I'm applying it as a pressure here or force at the third circular hole, and I am applying it vertically down. And what is happening here is that you can see that as I am changing the direction of the force and the application of the force where I am applying that particular force, you can see that the bearing, the stress distribution is again changing. Okay. Now you can see that without actually building the square plate and actually having the square plate in my hand and applying different force conditions, I'm doing this virtually, and I can see that how the plate will react for different forces. Okay, and this is quite useful feature, and that is what I was telling earlier, that in a virtual world it is very important and very easy nowadays to build a digital prototype and do the simulations and find certain properties and answers of our solutions and how it will affect the material. So this is what I try to do. So that this is generally the activity which we generally try to do. Okay, and this I will now demonstrate to you. Okay. Okay. So let me demonstrate the activity to you now. Okay. So for this activity, what I'll do is I'll just open. I'll be using the Fusion 360 software, which is very easy, okay, to use. And Fusion 360 software student version is free to download, and you can download if you are interested, and you can also study the software. Lots of tutorials are available. Okay, so what I have done is here you can see that I have already built a square plate with three circular holes. Okay, what I'll do now, I'll just go here in the design, and I'll go in simulation, and I'll create a static stress study. Okay, now for this, let me first apply the constraint. So I'll apply the structural constraint here. So unless and until you don't apply structural constraint, because our plate was fixed, correct? So I'll just say here I'll apply some structural constraint. So I'll just select these surfaces, and I'll say these are pin constraints. Okay, so I selected the pin constraints here. I'll show you again. So I just selected, you can zoom in if you want. This one's face, this another face, and just say okay. Okay, now after doing that, I'll apply the load here. So say structural load. I'll select pressure here, and I'll select this particular face. Okay, I'll say change unit, instead of megapascal, I'll go to say Pascal, and I can say 160. 160. Okay, I'll say 160 pascals. Okay, I'll just try to apply here the pressure, and that's the unit. Okay, and I'll say okay. There are so many different further uh, criteria. As you can see, you can apply force, pressure, moment, bearing load. You can apply bearing load also. So if you want to apply bearing load here, you can. I'll just change it to bearing load just to show you how we can change the direction. So I'll say 160 Newton, that, and then I can change the direction. I can do it vertically down, and I can say okay. So you can see that now we have just applied the vertically down. Now I have a green tick here. That means my pre-check is fine, and I'll just say solve, and I'll just solve this locally. And it will take some time to solve this particular solution. So once I solve this, okay, and I get different types of solution here uh, based on my different loading conditions. But basically what I want to show you here is that we get certain type of results, and those are the results which we call it as a simulation results. Okay, and you can see that these are the simulation results which I got. So I'll just close this, and instead of a safety factor, if I select here stress, so you can see that I got the stress results. Okay, so these are my stress results, and you can see that here if I just see which area is more stress. Okay, so you can see that, and I will just try to zoom this. You can see that there are some red patches here, so that means highest stress, and these are the values of the highest stress. Okay, but what we can see here is that if I just try to see, so these are some of the areas, okay, which are highly stressed. Okay, but there are some area like here, here, and here, there are no there are not many stresses, and that area is too safe. Okay, now of the problem for this plate which I want to pose here is that, so if only this area which is right now colored is actually exposed to more stress, correct? So do we really require these areas which are here as a part of this plate, or you can just remove it and still it can bear the same pressure? Is it possible? If I want to make optimum solution, or if I want even whatever the stress is to change, and I want to bear more stress, more capacity, what are the possible solutions? Okay, so you can see that I just want to show you here that, okay, so I'll just go here in study materials, and you can see that this is currently steel. Okay, so I'm just trying to give you some ideas, and so that you can come up with some solutions. Okay, so this is the material which is currently there. Okay, but if I want more strength and more stress bearing capacity, what are my possible solutions? When I go in results, okay, do you really require this entire square plate as it is, or we can still reduce some weight and still we have a bearing load capacity? What can be the possible solution? How we can do that? How we can find out the optimum solution for this given problem, where we can still apply 160 Newton here at this, but still our particular square plate can withstand that load. So this is what we are trying to find it out, and this is what we will try to see if we can get certain solution results out of that. Okay, so I hope we can discuss this further when we'll try to find out the answers of this. Okay, and just let me see if I can show you. Yeah, so you can see that when we apply certain force here, how the results are basically generated. Okay, so this is just an animation which I am showing you. Okay, so the problem which I am posing here to you is, think that whether we still require as a bracket this square plate only, or we can perhaps do something so that this will become strong and this will bear more load. What can be the possible solutions, how we can make this more strong and it can bear more load? Is really the square shape is required, or we can still bear the same load but change the shape, and how that is possible? Is it possible? How that we can do that? So we'll try to find out some of the solutions of this, and we'll try to discuss what is optimization and how iterations will come. So this solution is our first iteration, and in iterative design, how we basically think and how we go for next iterations, and what is possibly help us to take our decisions, where creativity will come into picture, and how we can use that creativity to find out more refined solutions, and all these things we'll discuss when we'll meet next time. So this is what for today, and I hope you will enjoy this, and we'll definitely try to find out the solution of these problem what we have discussed today, and we'll discuss further one to one, and I like you to talk more and your ideas and your solutions to come up to discuss this problem and how we can do that. So I hope you will enjoy to solve this particular problem, to find out certain solutions and discuss that when we'll meet next time. So thank you very much, and hope to see you all in our next session.